Hi, this is Professor Michael Wysession. I'm outside my Department of Earth and Planetary Sciences at Washington University in St. Louis. What I want to do here is give you a quick example of something you can take into the classroom to help address a very challenging Texas tech. And these are the standards that address the size and scale of the universe, a very challenging topic. I mean, the distance across the observable universe is almost 100 billion light years. This is about 1 septillion kilometers, or 10 to the 24th kilometers, a truly incomprehensible number. But if you break it down into 3 steps, I'll show you how you can use analogies to make this understandable to your students. Let's start with the solar system. Now, the solar system is still huge. The distance from the sun to the earth is 150 million kilometers. The distance to the edge of the Kuiper belt, that's the belt that contains Pluto and other similar bodies, is about 50 times that, or about 50 astronomical units. So the distance across that inner solar system there, out to the Kuiper belt, is about 100 astronomical units, or 15 billion kilometers. Very hard to comprehend. But let's say that the Earth is this penny. That's something that the students come across in there every day. If the Earth is the size of a penny, how large would the solar system be? Well, it turns out it's about 23 kilometers, or about 14 miles. And this is also a distance that's in the student's everyday life. So you could, for instance, use a map showing the distance to a nearby town that would be 23 kilometers away, or a nearby landmark. And this begins to give the students an intuitive sense of how large the solar system is. Now, if we want to move up to the Milky Way galaxy, I'm going to need a little bit more room. Hello, here I am in Brookings Quad at Washington University. I needed a little bit more room here to talk about the size of the Milky Way galaxy. So, the Milky Way galaxy, with its hundreds of billions of stars, is enormous in size. It's about 120,000 light years across. This is about a septillion kilometers. Well, how do you begin to grasp that size? Well, we can use the penny again, but this time I'm going to let the penny be the solar system. So if the whole solar system, the sun and the planets, the Kuiper belt, is all within this penny, how large do I have to go in order to encompass the whole Milky Way galaxy? Well, it turns out the Milky Way galaxy would have to be about 1,400 kilometers in comparison to our solar system as a penny. 1,400 kilometers is a little bit larger than the size of Texas. So again, now we have a scale that students can understand. If the whole solar system is this penny, then the Milky Way galaxy is a little bit larger than the size of Texas. Now, we have one more step to do, and that's the entire universe. And I need even a little bit more room. Hi, here I am on the main green at Washington University to talk about the whole size of the universe. Now, before I do, you may have noticed I've been using several different units, and that can be a problem for students because there are so many different ways to describe a single distance. For example, the nearest star, Proxima Centauri, it's 4.2 light years away. But you might also see that in terms of 270,000 astronomical units away from us, or in terms of it being 40 trillion kilometers. Nonetheless, for a student to understand that, it's better to use some kind of an analogy. If our penny was the solar system in the previous example, then the nearest star, Proxima Centauri, would be about 51 meters away, or about half a football field. Again, a football field is a familiar thing for students, so that analogy gives them a better intuitive sense of how far that distance is. Well, let's go all the way out now to the observable universe, somewhere between 90 and 100 billion light years across, like 10 to the 24th kilometers, incredibly large. If we take our penny a third time, though, and let the penny be the Milky Way galaxy. Now, the sun is a tiny speck on this penny, and the swirling arms of the Milky Way galaxy fill out the edges of this penny. In that case, the observable universe turns out to be about 15 kilometers across, or about 9 miles. Again, that's a distance that students would be familiar with, a town nearby, or some place that they might go for a sports game or visiting relatives. And so you can see now that by doing this exercise in 3 steps, all involving a penny, we end up with 3 distances that are in the students' everyday lives, going from the Earth out to the solar system out to the Milky Way, and the Milky Way out to the universe. The distances are still huge, but this analogy gives the students a better chance of understanding this very complicated standard.